Hi everyone, in this video I am going to explain light, reflection and refraction. So let's talk about light. What is light? When we talk about light, it is a form of energy which enables us to see an object. Is it no? So when we talk about light, so it's a form of energy. We are able to see any object because of light. How? See, whenever light falls on the object and after reflection it reaches to our eyes, then we can see the light. Yes or no? So here we have few concepts like what is ray of light, beam of light. Let's see. Okay, we talk about ray of light. A ray of light is a straight line along the direction of motion of the light. This is a ray of light. It means light is traveling in this direction. If a ray of light is here, so it means light is traveling in this direction. Yes or no? Now, what do you mean by beam of light? A bunch of light rays or a bundle of light rays is called as beam of light. Okay, a group of light rays is called as beam of light. So we have three types of beam of light. One is parallel beam of light, another is convergent beam of light, next divergent beam of light. So let's see the definition. Okay, parallel beam of light. A group of light rays parallel to each other is known as parallel beam of light. Okay, so whenever light rays are not meeting at any point, so this is called as parallel beam of light. Divergent beam of light. A group of light rays spreading out from a source of light is called as divergent beam of light. So here, suppose this is a source of light and light rays diverging. Okay, now convergent beam of light. A group of light rays meeting at a point is called as convergent beam of light. Okay, so suppose this light ray, and this light ray is a meeting at this point. So this is what a convergent beam of light. Is it clear? So let's talk about a reflection of light. Okay, reflection of light. See what happens, the phenomenon of bouncing back of light ray, okay, when it strikes any surface is called as reflection of light. So this is a surface, light is incident on it, it bounces back. The light ray which falls on the surface is called as incident ray, which bounces back is called as reflected ray. And if you draw a 90-degree line, so this is called as normal. The angle made by incident ray and the normal is called as angle of incidence. Angle made by the reflected ray with the normal is called as angle R, that is angle of reflection. Yes or no? We have two types of reflection, okay, and two laws of reflection also is there. You must know laws of reflection. The first law, at the point of incidence, the incident ray, the reflected ray and the normal all lie in the same plane. And second one, the angle of incidence is equal to angle of reflection. Okay, so when you see first law, the incident ray, the reflected ray and the normal at the point of incidence all lie on the same plane. And second is what? The angle of incidence and angle of reflection both are equal. Angle I is equal to angle R. Yes or no? So that is the second law. Very important. They may ask for 2 marks. Okay. When we talk about types of reflection, we have again two types of reflection is there. One is regular reflection, other is irregular reflection. What happens in regular reflection, when parallel beam of light ray falls on a plane surface, the reflected lights are also parallel. That is called as regular reflection. In irregular reflection, if a parallel beam of light ray falls on a rough surface, this surface is a rough surface. Okay, the reflected lights are not parallel. Okay, they will meet somewhere. So this is called as irregular reflection or diffused reflection. Yes or no? So you can note down the definition if you want. Regular reflection and irregular reflection. Next, you should know there are two types of image. One is real image, other is virtual image. Okay, so let's see what is real image. The image which can be obtained on the screen is called as real image. So generally the real image is formed when the light ray is actually meeting at a point. Suppose this light ray and this light ray is meeting at this point. So which type of image is formed? A real image is formed. Okay, real images, so it is formed by the light rays after reflection or refraction when they intersect each or converge at a point. Size of image depend upon the position of the object, where we are keeping the object. See, remember one more thing, real images are always inverted. Real images are always inverted. Okay, and it can be obtained on the screen. Okay, it can be obtained on the screen. Okay, now when we talk about the virtual image, suppose this is one light ray and this is another light ray, they will meet? No. But once you produce it backward, they will appear to meet at this point. Yes or no? So what is formed? A virtual image is formed. A image which is formed when the light ray appear to meet at a point. Okay, virtual images are always erect and it cannot be obtained on the screen. Yes or no? So these are the main points you can remember. Okay. Okay, here some definitions are there. Light is a form and session of light. It provides communication and electromagnetic radiation. Okay, what is the speed of light? Remember, speed of light is 3 into 10 to the power 8 meter per second. Okay, so the definitions are there: incident ray, reflected ray, normal. Okay, so you can see. You should also know the characteristics of image formed by the plane mirror. Let's see, plane mirror is there. Okay, let's take this is a plane mirror. AB is the plane mirror, and here one object is there. PQ is the object. Image is formed behind the mirror. Yes or no? How is the image? Virtual. So Q dash and P dash image is formed. Remember one thing: the image formed by the plane mirror is a virtual and erect. Which type of image it is formed? Virtual and erect. See, that object is suppose 2 meter in front of mirror. So image will be also 2 meter behind the mirror. So we can say distance of image behind the mirror is equal to distance of object in front of it. And suppose the height of object is 2 feet. So height of image will be also 2 feet only. Height of image is 2 feet. So we can say that height of image is equal to height of object, or image is of same shape and size. And it is laterally inverted. Laterally inverted in the sense, if you raise the left part, image will be raising the right part. Yes or no? So left part of object becomes right part of the image. This is called as laterally inversion. Lateral inversion. So image is what? Laterally inverted. So this question may be asked okay, for 2 marks. Please make a note of this. Magnification of plane mirror is +1. Remember, because magnification is nothing but the height of image to the height of object. But as in case of plane mirror, the height of image and height of objects are same right now. So magnification is what? 1. Okay, MCQ question. Okay, now let's start with the spherical mirror. Okay, talk about the spherical mirror. We have 2 types of spherical mirror: concave mirror and convex mirror. So concave mirror, you see here. When we talk about concave mirror, it is a mirror, spherical mirror, okay, whose outer part is polished, inner part is reflecting part. Whereas convex mirror, what happens? Inner part is polished and reflection takes place through the outer part. Yes or no? See what happens? Concave mirror is also called as converging mirror. Okay, because it will converge the light ray falling on it. Here this is called as diverging mirror. Let's see. Spherical mirror, the reflecting surface of a spherical mirror is curved, maybe inward or outward. Concave mirror, spherical mirror whose reflecting surface is curved inward is called as concave mirror. So light hit inwards, that is concave. Convex mirror, a spherical mirror whose reflecting surface is curved outward. Okay, so here inside it is polished, so reflecting surface is curved outward. This is the outward. A concave mirror, this is reflecting surface is this side, curved inward. Yes or no? So you can see, okay, light ray is falling here in this side, and this side is what? Polished. Here few terms are there. Definition you can note down, like aperture. What is aperture? What is the pole of the mirror? Center of curvature, radius of curvature, principal axis, focus. Okay, so these are the various terms of a mirror related to the mirrors are there. Okay, please make a note of this. Okay, aperture, the width of the reflecting surface from which the reflection takes place is called as aperture. Okay, so let's see, one concave mirror is there, AB. So the light is falling on this surface, this point right now. So this is what? Aperture. Okay, this is the aperture of the mirror. Okay, pole, the central point of the reflecting spherical surface, okay, is called as pole. So this is the spherical mirror. concave mirror, this point is pole. Here you can so go through this diagram also. Okay, pole, this is the pole of the mirror. Okay, center of curvature of the mirror. So this is the, assume that it is a hollow spherical glass, and if you cut this part and polish this part, okay, so this is a concave mirror. In this part, if you see, if you polish from inside, so reflecting part is outward, it is what a convex mirror. Yes or no? It will behave as a convex mirror. So C is the center of curvature, P is the pole. The line joining center of curvature to the pole is called as what a principal axis. Okay, here we have principal focus. The distance from P to F is called as what a focal length. The distance between P to C is called as what, radius of curvature. Yes or no? So this is what a hollow sphere is there. This is concave mirror. This side is convex mirror. Okay. Similarly, pole, center of curvature. P to F distance is what, focal length. P to C distance is what, a radius of curvature. Okay. And the line is what, a principal axis. Here all the definitions are there. You can note down. What is pole? The central point of the reflecting spherical surface is what, called as pole. Yes or no? Now center of curvature, the center of a sphere of which a spherical mirror is a part is called as center of curvature. Radius of curvature, it is a radius of a sphere of which a spherical mirror is a part. Okay, principal axis, the straight line joining the pole and the center of curvature is called as what, a principal axis. Okay, focus, the point on the principal axis where the beam of light parallel to the principal axis meet after reflection. Okay, so what happens? Suppose this is a mirror, concave mirror. Suppose this is the pole, this is the principal axis, this is the center of curvature. If a ray of light is parallel to the principal axis, after reflection it will meet at a point. That point is called as focus in case of concave mirror. In case of convex mirror, you see, if it is a convex mirror, this is the pole. Okay, this is the center of curvature. If a ray of light is parallel to the principal axis, this is the principal axis, it will diverge. It will appear to pass through one point. That point is called as what, a principal focus. And the distance from P to F is called as what, a focal length. Okay, we have a focal length. Okay, the distance between the P to F is called as focal length. Now we should know the rules of image formation in case of a spherical mirror. First rule, let's start the first rule. A ray of light parallel to the principal axis will pass through the principal focus. Suppose this is the concave mirror. Okay, this part is polished. This is the principal axis. If a ray of light is parallel to the principal axis, after reflection it always passes through focus. If it is a convex mirror, okay, inner part is polished. If a ray of light is parallel to the principal axis, after reflection it will appear to pass through focus. Yes or no? This is the first rule. Second rule, a ray of light will emerge parallel to the principal axis after reflection from the mirror, passing through the principal focus. Okay, so when you see this ray of light is passing through the focus, after reflection it becomes parallel. Or if a ray of light is directed towards the focus, after reflection it becomes parallel. This is the second rule. Next, we talk about the third rule. Okay, third rule is like this: a ray of light retraces its path after reflection passing through the center of curvature. Now see, this is the F, this is C. If a ray of light is passing through C, it will bounce back. Okay, similarly, if a ray of light is directed towards C, okay, in case of convex mirror, it will bounce back in the same direction. Okay, it will retrace its path. Now fourth rule is there: a ray of light gets reflected at the same angle on the other side of the principal axis, incident obliquely at the pole. Suppose this is the pole and ray of light is incident at angle I, so it will reflect back at angle R, and angle I will be equal to angle R. Yes or no? Similarly here, this is a convex mirror. If a ray of light is incident like this, it will bounce back at the same angle. Suppose this is 30 degree, so this will be also 30 degree. Yes or no? So these are the rules of image formation in case of convex lens and convex mirror and concave mirror. Please make a note of this. Next, where we are using the concave mirror. Okay, you can see, and a spherical mirror whose reflecting surface is curved inward is called as Concave mirror, example, inside part of a spoon. If you see the spoon, the inside part, if you are seeing your face from inside part, it is a concave mirror, acting as a concave mirror. So light reflects inside of the curved part. Where we are using the concave mirror? Generally in torches, searchlights and vehicles. Okay, it is used as a saving mirrors to see the large image of the face. It is also used by the dentist, okay, to see the large image of the patient teeth. Even it is used in solar furnace. Yes or no? So these are the uses of concave mirror. Let's talk about the convex mirror. Image formation by concave mirror is there. Okay, before that you will see convex mirror, a spherical mirror whose reflecting surface is curved outward. You can see here. Okay. So this part is polished. So reflecting surface is what? Curved outward. We are seeing the from this side. So in the spoon, if you see from this side, bulging out part, so this is a convex mirror. Where we are using the convex mirror, it is used as a rear view mirrors in vehicles. These mirrors enables the drivers to view the much larger area. Okay, parking mirrors also for looking through the sharp corners in automated teller machines. Okay, as a simple and handy security features. So these are the features of concave mirrors uses. Okay. Now we will see the image formation by the concave mirror, very very important. Here question may be asked for 3 marks. We will keep the object at different places and we will see where is the image formed. Okay na? So first let us take the object is at infinity. Where is the object? At infinity. So this is the object, A, B is the object infinity. You should know whenever the object is at infinity, the light ray will come parallel. Okay, so here you can take two light ray, this light ray and this light ray is coming parallel. As the rule says, if the ray of light is parallel to the principal axis, after reflection it passes through focus. Same, if a ray of light is parallel to the principal axis, after reflection it passes through the focus. Now this light ray and this light ray is meeting at one point, where? Focus. So there only image is formed. Which type of image it is? Image is at focus, the image is real. As you know that real images are always inverted and it is point size. Is it okay? Next case, object is between C and infinity. You bring the object beyond the C here. This is the C. Okay, here AB is the object. Again, two light ray diagram is important. Okay, for the image formation, one light ray you take parallel to the principal axis. After reflection, it passes through the focus. Second, you pass through C only. So it will bounce back. Now this light ray and this light ray is meeting here between C and F. So where is the position of image? Between C and F. What is the nature of image in this case? Image is real, inverted and it is diminished. Okay, diminished or smaller image we can say. Now next case, when the object is at C, here object is at C, AB is the object, means it is at center of curvature. You take one light ray which is parallel, after reflection it passes through the focus. Second, you pass through the focus, it become parallel. Yes or no? So this light ray and this reflected light ray is meeting exactly at C only. So A dash B dash image is formed. Okay, image is at C only. In this case, image is real, inverted and same size. Image is real, inverted and same size. Is it clear? Please make a note of this. Okay. Next, when the object is, okay, question number 4, when the object is between C and F. Okay, this is C and let's say this is F. Object is between C and F. So one light ray you take parallel. Once a ray of light is parallel, it will pass through focus. Yes or no? Second, what you do, you just direct towards C only, incident towards C.